Good morning to all of you. I welcome you all. Today we are going to see the topic of refrigerant and its types in the first unit. Refrigerant. A refrigerant is a substance or mixer, usually a fluid, used in heat pump and refrigeration cycle. It means refrigerant is a fluid. It may be a gas or vapor. It used in heat pump and refrigeration cycle. In most cycle, it undergoes phase transition from a liquid to gas and again gas to liquid. Primary and secondary refrigerants. Fluids suitable for refrigeration purpose can be classified into primary and secondary refrigerants. First one is the primary refrigerant. The primary refrigerants are those fluids which are used directly as a working fluid. It means primary refrigerant directly absorb the heat from the storage space and undergo a cycle. The next one is the secondary refrigerants. As the name implies, secondary refrigerants are those fluids which are used for transporting thermal energy from one location to other. It means the secondary refrigerants are first cooled by the primary refrigerant and they absorb the heat from the storage space. So the secondary refrigerants are also known as under the name of brines and antifreezers. Refrigerant selection criteria. Due to several environmental issues such as ozone layer depletion and global warming and availability of variety of refrigerant in the market, the selection of suitable refrigerant has become one of the most important issues in recent times. We follow the certain requirements to choose the refrigerant. The selection of a refrigerant for a particular application is based on the following requirements. The first requirement is thermodynamic and thermophysical properties of the refrigerant. And second requirement is environmental and safety properties of the refrigerant. Third requirement is economical point of refrigerant. The first requirement, thermodynamic and thermophysical properties. Here, the first requirement, suction pressure. At a given evaporator temperature, the saturation pressure should be above atmospheric for prevention of air or moisture ingress into the system and ease of leak detection. It means to avoid leakage of air from atmosphere into evaporator. For given evaporator temperature, the suction pressure should be greater than the atmospheric pressure. The second one is discharge pressure. At a given condenser temperature, the discharge pressure should be small as possible to allow lightweight construction of a compressor. If the discharge pressure is high, suction pressure is low. Suction pressure is high, discharge pressure is low. The work requirement is minimum. Third one is the pressure ratio. The pressure ratio should be small as possible for higher volumetric efficiency and low power consumption. Next, latent heat of vaporization of refrigerant. The latent heat of vaporization of the refrigerant value should be large as possible. It required minimum amount mass of refrigerant for cooling purpose. The next one is the isentropic index of compression. The isentropic index of compression value should be small as possible so that the temperature rise during compression will be minimum. So we should take minimum isentropic induction value. The next one is the liquid specific heat. It should be small so that the degree of subcooling will be large, it leading to smaller amount of flash gas at evaporator inlet. Vapor specific heat of refrigerant. This value should be large so that the degree of superheating will be small. The next one is thermal conductivity of the refrigerant. The thermal conductivity of the refrigerant in both liquid phase as well as vapor phase should be high for high heat transfer coefficients. The next one is the viscosity of the refrigerant. Viscosity of the refrigerant should be small in both liquid and vapor phases for smaller frictional pressure drops. Now another requirement is environmental and safety properties. Environment friendliness of the refrigerant is a major factor in deciding the usefulness of a particular refrigerant. The first environmental and safety property is ozone depletion potential. The ozone depletion potential of the refrigerant should be 0. The refrigerant should be a non-ozone depleting substance. Suppose if the refrigerant having non-zero ozone depletion potential value already been phased out or it will be phased out in near futures. So the ODP value should be 0. Since the ODP value depends mainly on the presence of chlorine or bromine in the refrigerant. Second one is the global warming potential. The refrigerant should have a low global warming potential value as possible to minimize the problem of global warming. The next one is the total equivalent warming index. This factor consider both direct and indirect contribution of refrigerants to the global warming. So here direct means the refrigerant leak into the atmosphere. Indirect means the power requirement of the refrigerating unit. So naturally refrigerant with a low value of total equivalent warming index are preferable from global warming point of view. Flammability. The refrigerants should preferably be non-flammable and non-explosive. The flammable refrigerant, special precautions should be taken to avoid accidents. Chemical stability. The refrigerant should be chemically stable as long as they are inside the refrigeration system. Economic properties. The refrigerant used should preferably be inexpensive and easily available.